Now we're going to move to where the problems are still real and they're large and they're being grappled with. We're going to move to East Asia. And I'm going to call on Professor Deliang Chen from the University of Gothenburg to talk about aerosol pollution in East Asia.
Okay. Thank you, Will, and good afternoon, everybody. Very happy to be here to share with you some of our work, and so my talk will be based mainly on our own works, but also I will have cite a few very recent work which actually has taken us further into the linkages between what's happening in Asia and the rest of the world. So the two pictures here, I think, can give you some sense of how serious the problem is. And also, I found also that the Paris talk is really fascinating, and China, Asia is really started to see some of the things happening, and also there is indeed a lot of discussion nowadays between the climate and the air pollution issues in that part of the world. I guess just say what I should. I think I just say okay. Oh, that must be the power supply. Yeah. There we go. Thank you. Thank you. So let's see how this works. Yes, I started actually with the key points I would like you to be convinced of in the beginning, and then we'll see after my talk if you are convinced a lot. So my first point is really that Asia is currently the most significant source of air pollution, including the SO2. I think that is basically a fact. There are many data about that. And but we do need to look at some of the data. And the second point is that, of course, aerosol has a local effect. And that is also probably quite easy to imagine. And most often we think about the effect on solar radiation and maybe temperature because of the heating, the energy balance. But I'm going to show you actually other meteorological climatic variables are affected too, like precipitation and even wind. The third point is that actually because of the location of the Asia, is located in terms of energy, it's a quite energetic area. So you have a lot of atmospheric dynamics and a lot of heating, and which makes actually the transport process very effective. What is happening in Asia can be fairly easily or relatively easily transported to other parts of the world in comparison to Europe and even to North America. That is potentially important because that what's happening in Asia probably is not just bad or good for Asia, maybe also can be linked to eventual problems that we are facing, for example, in Europe or in North America. And the last point is that we all know that the global change is happening, not least the warming, but actually there's another phenomenon we call the global steaming. That is, there are a lot of evidence showing that the global near-surface wind has been slowing down. So the wind speed is decreasing, especially in the northern hemisphere. So how this will have effect on the aerosol, air pollution, and also some of the climate effect is also, I think, is to be important in the future. So let's first take a look at the emission data. I think this data provides some additional information to what Henning has already shown us. And if you look at, for example, the emission from East Asia, that is a global anthropogenic SO2 emission, you see that actually while the Europe, America are basically going down, the Eastern Asia is going up. It's really taking over. And this is very much linked to, of course, population, especially urbanization. And this is a diagram showing the urbanization in different parts of the world, and basically in 3 different time slides. One is around 50. Second one is at moment, and then also some prediction for the future. And you can see that Asia is high, the increase of the urban population, and it will be even higher in some decades in the future. Of course, if you look at a map like big cities in the world, you see that I think, very close match to what you have seen from Henning's slides. Europe, North America, and Asia are the three regions that are probably the most densely populated. And of course, population has a strong link or need for energy also. So the urban air quality, and when we talk about urban, in the Asian context, I have to say not just urban. Basically, if you're going to Eastern China, which I will show you a map later, it's basically everywhere in Eastern China. Cities are linked to each other. If you take train, you can travel 1,000 kilometers along the eastern coast of China, and you see the cities after cities almost non-stop. So really, the urban air quality is not just a problem of very locally at the urban scale, but also a regional problem. It's, of course, strongly influenced by human activities. And the human activities here, you can see in the background, is mainly the power plants, the coal-firing power plants, and also some industry activities. And of course, traffic is another problem. And just in Beijing, you have now over 3 or 4 million cars, I think, private cars, which is amazing. I left China some 30 years ago. At that time, I could not even dream of having a private car. And then now, and some families have 2 or 3 cars. So it's also an increasing problem. That is the area, actually. That's a picture taken by NASA, and it's linked to very much to what Henning was engaged in this ABC program, and showing basically there is a smoke. It's quite large scale, covering the whole East Asia. So we are talking about aerosols here, and when I started to look at that problem myself, and I was trying to get some data, especially for China, and was actually, so I'm a little bit, I feel that Europe, of course, you had the problems before us, but you also started very much earlier with scientific endeavor, such as the monitoring. But in China, actually, if you look at the aerosol data, it's only some 15 years ago we started to measure the aerosol and air pollutants. And much of the data are secrets, as no way to get the data. So when I started some 10 years ago, and what we did is that we look at the newspaper. In the newspaper, I started, I think, from 2001 or something like that. They have an air pollution index on the newspaper every day. So we started with that. And we went through all the newspapers day by day, about 6 years. And we tried to translate that information into the aerosol. And there is some formula, and we kind of both have had good contact with people who created this index. But the data we cannot get. That's really an issue. And we thought that we have only 5-6 years data in that time. What do we do? And then we were thinking about maybe we can look at something like a weekly cycle. Of course, there was already some work has been done for North America before us. But we thought in China, and you must have a very strong signal of that. Namely that there is a clear cycle of human activities, as you know. Even Chinese people take rest on Sunday. And so there is some kind of slowdown of activities on Sunday. And so that should have maybe a signal in the air pollution. And we also hoped, we did not expect that we will see a strong signal in the weather, temperature, humidity, wind, radiation, etc. Actually, we did see a very strong signal of that. And we went through that. Then we said, okay, you have certain holidays, like big celebrations, Spring Festival in China, like New Year. All the fireworks should have also impact. And also we did actually identify all these kind of signals in the data. So let me show you. And also, of course, and as a scientist, we need to explain if how these cycles are linked to each other, because there are some interactions between aerosol, heating, cooling, and then the wind come in, the boundary layer dynamics come in, then you have also the clouds, etc. So let me show you some of the slides of what we found. So these are the points where we have the PM10, we call it PM10 stations, but actually it's cities where you have some information about PM10. Actually, I'm sure that information when we talk about PM10 is much more about PM10. Is also PM 2.5 because this is index. And also you try to use of course the meteorological data. We analyze this. We also have the radio sound stations. And in this map, so basically this is the eastern part of China where you have a lot of pollutions. And of course you can see even from that translation you can have values something as high as 120. And today we know that number is much, much underestimated. But at that time, that's what we could do, actually. So then we did a very simple plot. We have about, I think, 5 years, 6 years data. So we rearranged data into weekdays. So all the Mondays together, all Sundays together. Then you plot this diagram. And of course, as you can imagine, you have weather. That is a synoptic scale. So you cannot expect that every Sunday will be similar. But you have so many Sundays, you should have some signal, and which is the case here. And as you can see, there is a clearly signal of the weekly cycle of the air pollution. So it started from Monday, it's pretty low, and it increased Tuesday, and then Wednesday seemed to be the top. And then we started to ask our question, why not Thursday and Friday? Because it's continued to accumulate. It turns out, as I will show you later on, that actually by Wednesday, because of the accumulation of aerosols, then other processes are triggered in, such as the boundary layer dynamics, the vertical transport, etc., which actually increase the wind speed. And that wind speed helps to dilute the air pollution. And so it is going down again. And when we did that first, we did for the all data together. And then we thought, well, aerosols should be washed out fairly easily by rain. So we should also take a look at the long rain days. And actually, as you can see, actually, it does not matter too much on that time scale. It seems to be the same pattern. So then we have a look at the temperature anomaly. And very interestingly, that it has also weekly cycle, clearly. And the thing is that we did the same thing here, but as you can see, we also look at the T maximum temperature, basically is the indicator for day temperature. We also look at something called the DTR, the diurnal temperature range. That is the maximum minus minimum, which shows the pattern are similar. This is an indication that this is basically a daytime phenomenon. It's a shortwave radiation phenomenon. So in the light, it does not matter too much. And also interestingly, actually, if you look at this anomaly of temperature, you have some heating effect too. Until Wednesday, there seems to be some heating. Then you have the cooling, as we usually believe. And we all know that air also has two kinds of effects. One is direct, the other is indirect. The indirect effect is what Henning talked very much about the uncertainties about. And so that is also why it is so complicated, because errors can behave differently under different conditions. So then we thought maybe have some effect on the rain. The clouds should have an important role here. So we look at the frequency of night rain events as a frequency, and we also look at the amount of the rain, which is similar. So just to save some time. But basically, you can see that by Wednesday, actually, there is a low frequency of the occurrence of the light rain. So the rain was decreased. Because of that, because of the heating, and then some process started to operate after Wednesday. By the way, the arrow bar really shows that we are the diurnal cycle is significant, despite all the uncertainties or the noises we have. So then we said, well, that is aerosol. We should take a look at the climate data. And we do have much, much longer climate data, in that case, precipitation. So we have something like, how many years? Study from 56, we have precipitation until now. So what we did is that, because what we have shown is that the light rain seemed to be affected the most. So we divided the rain into different categories. And let me see if this is the pointer, yes. So here you have the intensity of the rain. And these are night rains, basically 2 millimeter per day, 4 millimeter per day, until up to 5, 6 millimeter per day. And then you have heavy rains here. Of course, in China, everything above 50 millimeter per day is a heavy rain. In Sweden, we usually say 40 millimeter is a threshold. So if you do this, divide into different categories, then we found actually for the light category, below 5 millimeter per year, we see a significant decreasing trend. We were very glad to see that, which confirms what we have seen from the 5-year data together with the aerosol and the air pollution. So that was kind of indirect confirmation of what we found with the aerosol data. Of course, all these are statistic analysis. So we were not pretty sure we did get all this published, but we were questioning all the times, are you sure that is aerosol? Can you do some modeling work? And which we then did. But before we have done that, we were thinking about the 3 possible mechanisms. Number 1 is that, of course, there will be heating. And that heating will reduce the relative humidity, which most likely will lead to reduced rain occurrence. And secondly, it changes the vertical stability, which I don't have time to show you, but I will summarize all this later on. We did see actually a very significant weekly cycle of the vertical velocity in the atmosphere. And also, we did see a very clear signal from the stability on a weekly basis. And of course, the most tricky thing is the clouds. And it's, as you know, that the clouds are formed with help of small particles called CNN and cloud nucleation particle. So that, of course, should have an impact on the formation of clouds. At that time, we believed that this type of process can only happen when you have quite stable condition. It's only about weak or light rain. And I can tell you today that I have seen some recent study, which is not published yet, but I can tell you that it's done actually by Professor Xi's group, and he's sitting here in the audience. They have even showed today that even that aerosol actually has also strong impact on the strong rain also. So we will look forward to see the final publication of that work. So just to give one picture summarizing what I have said about the heating on the surface. And also we plot the temperature in this cross-section again from Sunday to Saturday. Here is the height, the vertical height. So here is about 2 kilometers. As you can see that starting from Monday, it's cooling, it's heating close to the surface. And that warming seems to be moved to the higher level as the weeks goes. And so this is, of course, a reason that the vertical stability is changed. Then we did a real, I'm not very good at the cloud processes, microphysics, so we went to a laboratory in the States, and we did work together. And so what we did is that we had a cloud resolving model. By the way, the first also, Qing, I think Henning knows him. He visited you some years ago, and also he told me many times he also was inspired very much by you, and he's doing very well in the States nowadays, doing the aerosol interaction climate. So he and I, and also a few in my group, we did the work together. We have been running their model with cloud and all microphysics, and we have been running the model with different rain intensity. And we look at 3 cases. One is more like, I think C is clean, is a background, is very clean. In other words, aerosol concentration is low. Another case is a medium, in the middle. And also we run a case with heavy pollution, basically simulating what is happening in East Asia. So as you can see that it's very clear that for many of the intervals of the rain intensity here, actually the heavy case, the P case, has a lower number of the events for the night rain. So it's, of course, there are a few exceptions, but at most of the case, it's indeed confirmed what we have found in the data. So I think that was very interesting. To summarize what I have said, basically from Monday to Sunday, you have a cycle that on Monday, you have increasing emission, and you have the heating of the lower boundary layer, and which produce, of course, higher temperature. This higher temperature will destabilize the boundary layer and cause high surface wind speed. As you know, wind speed basically is a momentum transfer from the high level to lower level. So when this wind speed is increased, of course, the pollutants will be diluted, so the concentration will going down. And but the emission still continues. So but because of the increased wind, the air pollutants, it goes down. And then until Saturday, Sunday, there's a decreasing of the emissions. Then you have a decreased emission and also heating and wind, which complete a cycle and which can really confirm, I think, explain what we have seen in this nicely weekly cycle. So then move on. That is kind of local effect, which more or less we can expect. Then I think it's also coupled to what Per-Inge has said. There were some transboundary issues, and we have this issue also in Asia. There's a lot of debate between China and Korea, for example, and Japan. In that case, recently we just did the work for Korea. So we look at basically all the episodes, the high aerosol concentration days in Korea and in Seoul in that case. And we try to trace back the source. And basically what this is a diagram showing the anomaly of the stations in China. So when it is 80, for example, to 160, it is higher than normal, higher than the mean, so it's very high. And as you can see, actually almost all the episodes in South Korea can be traced back to the high concentration. And also, this is a trajectory, and this is one day, 2 days, 3 days. So basically, you can see very clearly, even within 3 days, the source is indeed coming from China. And I was careful. I did several checks before we published this paper because I don't want to insult my Chinese colleagues. So but we were sure scientifically it's kind of proven that is the case. There's another one that is not our work, but I find is really, really interesting, which also put all this work into a much larger context. That is a recent work published in last year. And what they did is that, actually from the US, group in US, what they did, as you know that all the processes I was talking about, the boundary layer processes, the clouds, are too fine to be resolved by global climate model today. What they have done is that they embedded a clouds resolving model into the global model. So that model actually is a global model, but it resolves the clouds processes with aerosol. So what they have done is that they have 2 cases. One is to have a situation of present day. The other is pre-industrial, it's clean. And they focus on this Pacific region, Asia and Pacific region. And so they have looked at, in that diagram, for example, is the aerosol optical depth, is the present day situation minus the pre-industry, which is basically the difference between today and the past. As you can see that the increase of the air pollution here, there is also a composition difference. You can see also this is sulfate is much larger in the present day situation. So just show you one diagram. They have gone through all the processes. And here, just 4 diagrams showing you this, of course, the aerosol optic depths after transport. And this is showing the liquid water pass, basically how much liquid water in the clouds in the atmosphere. And this is the ice water pass, basically showing the ice in a high-level clouds. You can see finally, this is the precipitation that we are familiar with at the surface. So all these diagrams show that there is a big difference and on a much larger scale than we thought in Asia only. And what they have concluded is that actually the over-increased precipitation and the poleward heat transport, so they also found that this also created an increased poleward heat transport from this part of the world to high latitudes and to the North Pole, which actually has a global implication. And so all this they have confirmed are due to the anthropogenic aerosols. I think this is a very strong statement to me, which is the first time that we have shown that the Asian problem is not just an Asian problem, it can be a global problem. And also it can really influence the storm track, the cyclones, which are not only important to the Pacific, but also to, for example, US, East Coast, and the polar regions. Of course, so the last point is that wind stealing problem I talked about before, that the wind is decreasing. This is a summary by Weird. And basically the wind is, this is the solar radiation. And so the solar radiation basically has been decreasing. There's a global dimming, has been talked about, until around 80. And then most of the part in the world, there's another brightening. So the solar radiation is increased. But what is the exception is that in India and in China, that is still decreasing. And so that, of course, is due to the increased aerosol and air pollution. So I did a very quick search on Google to find, if you use the keywords windy in Beijing and hazy Beijing, this is the pictures we can find. It's quite interesting that when you have the low, when the wind is windy, wind is high, actually it's a pretty clear sky. Of course, this is not really scientific. There are statistics also. Now we have some data, and thanks to actually a US embassy in Beijing, they released the air pollution data in China some years ago, which actually changed a lot of the data policy in China. So this is a typical situation in Beijing that you can see that when it's windy, that actually is very clean. So we have to look at that situation. And of course, the wind stealing problem in China is also very obvious. You can see the wind is basically decreasing, and the solar dimming is continuous. It's a little bit stabilized over recent decade, but still it's a problem. So we look at 3 regions in China. This is a heavily polluted region. This is kind of emitter. This is a relatively clean region in western part of China. And then we look at the radiation, and in 3 different regions, and also look at as a function of the wind speed. And you can see that the reduction of the solar radiation in heavily polluted region is as high as 15%. In the relatively clean region is 5%. And also that actually, if you have a high wind speed as high as 3.5 meters per second, that effect is basically gone. So, which is a confirmation that wind plays a very important role. And, but with the global warming, global change, that we probably will have we'll see a more negative effect on the air pollution. So finally come to the conclusion. Number one is that, of course, the Eastern Asia pollution has clear impact on local climate. And I haven't shown you the temperature precipitation, but actually we have evidence for wind and vertical stability also. Second point is that it has a remote effect also due to the transport process. Actually, the remote effect is quite larger scale. It can be intercontinental or even global scales. But I have to say that this is based on modeling, and so we still need some more evidence in the future. And I think in the global steaming, if this continues, that problem can become even worse. So the question is about how the aerosol air pollution has affected the storm trucks. And so that issue has been taken up by the last paper I showed you, but I did not show you the storm trucks. But in this paper, the main conclusion of that paper is that actually it has a clear and a significant impact on the storm trucks. And basically the strong cyclone has been intensified, become stronger, number one. Number two, the storm truck has been moved more northwards. So it has an impact both on the intensity and also the truck itself.